begin. I know we were dealing with this problem right here, and it was very messy. I think what I might do, there should be space in this corner. I'm going to make it a little more neat for everybody, or at least make it, actually, let's zoom in. All right, I know this was a little messy towards the end. I think notably around this area, 84, 96. I just want everybody to look at every little part. I know it's a little messy. I want everybody to see every little part of this parallelogram we marked. And basically, it goes back to triangle rules. The key was in parallelogram rules. Because from last time, we said the key was right here. FED was 134. Now, if we want, what you might want to do is draw another parallelogram. But here's how we're going to label it. Bless you. And we said FED was 134, yeah? Now, what do we remember about parallelograms? What do we remember about opposite angles? They are same. So if angle E is 134 or FED is 134, what about angle C? What must that sum be? And the reason why I want you all to do this, and it's similarly, D and F, well, what do we remember about the relationship between like either C and D or D and E? Name R, begins with an S or an L, a couple possible options. Or another way, what must, if we're going across or up and down, what must the sum of the two angles either going up and down or across, what must they equal? 180. They're supplementary, that's right. So the sum has to be 180. Now, given that's the case, if this angle is 134, what do we do with the 180 and the 134 to get the remaining amount? Yeah, so what's 180 minus 134? 46. So this angle's 46. This angle's 46. Because that's also going to help us regarding the little angles too. Because we were given that information that this little angle over here, I'm going to have to zoom out a little. Because we were told that this little angle is 21. Therefore, if that entire angle adds up to 46, if this part's 21, the other part has to be 25. And then basically with triangle rules, this is how we're going to get all of our other little angles. It's all about those triangle rules. I'll rewrite the 96 for that angle there. So that's how we get all these other angles. It's all about the math, folks. Now, here's what we have now. We do need this drawing. So if you want to make it a little bigger, I know it's going to get very messy, and I apologize. It does. I should have made this bigger. But the goal is here, we have to look at each and every little part. But we get it from the bigger parallelogram. But we get all these little angles as well from the triangle rules, just in general. Okay, I know that the sum of my angles inside the triangle has to add up to 180. I also know that from the parallelogram, if my overall big angle is, for instance, 134, then I know my smaller parts. And then vice versa, if my smaller angle, overall angle is 46, I also know my smaller parts. So it's really, a lot of it is a game in the end. The game is trying to figure out, given our information, what else do we need, or what else is left? All right, so this point, it's going to be messy, but here's how we're going to do this. So to answer these 4 questions, I know it's going to be very tricky, being that we want to. Okay, Christian, come on in. All right, do you have your notes from last time?
Yes.
Take them out. And do you have a pass? Oh, no, I know where you were, so no worries. Okay, here's what we're going to do. On your notes, so problem 7, so go to the next page, that's where we are. All right, on your notes, here's how we're going to figure out these angles. All right, for this problem, we've labeled all of our angles. I know it's going to be very messy, and I apologize. I think we're going to do this. How about this? We'll do this one together. We're going to do this problem together. So, DEC. Here's what's going on with DEC. Yeah, I'm going to have to zoom out a little. All right. DEC. Notice we start in this corner here, right? D is where we start. Do we agree? We start with D, yeah? All right, so I think so we start in the corner. This is D. Okay, if we're going to go from D, next we go to E. So are we going to the left or are we going down? Down. Now, point E, we need to go which direction? Do we go to the left or do we go towards the top again? Look at where our final letter is. C. So that means we have to go up. 63 degrees is going to be this angle here. DEC is going to be 63. Yeah, I know. Now, the next one's going to be a little different. So what we're going to do, we're going to start now. We start at now CDE. Where's our starting point? the top. Which direction do we go? Where's D? We're going down, right, left, up, to the right, and down. Now, be careful. I see we have a 25 and a 21. But what do we do with the 25 and 21? It's going to be 46 because you have to add them up. So CDE, that total is going to be the 25 plus 21. So I'm going to write 25 plus 21 here. Actually, and then you add them up. So that one's going to be 46. So all right, now ECD. ECD is going to be a little different because ECD, where do we start? What's our starting point? E at the bottom. Which direction do we go? And then to the right. So in the end, it's going to be the 71. I know this is not the best. And then you said the last one was? Very good. Yeah, that last one's going to be 25. And here's how Des got that 25. So from D. I don't like. Let me change that up. I'll go with this one. Go down, D to F, and then from F to E. And then look at the number where the turning point is located. Because the purpose is with these problems, the goal is, if we label everything, once we get all our angles, I know it's messy, it will take a little bit of work, but once you get all those angles, then you know exactly where your turning point's located. You know where your starting point, where you turn, and then the angle, the number where you see where you're turning, that's going to be your angle measure. So I know it was messy. I know it was a bit of work. But in the end, these are going to be some of those activities where we're going to have to work a little bit or work quite a bit to get a final answer. So it's not going to be just look at it done. No, there's going to be some work going on. We need to use some rules. So these are your four numbers, 63, 46, 71, 25. And that's how some of these problems are going to be. You're going to have to look at each little part. You're going to need to look at, okay, given this clue, what's my other clue? Or given this information, what do I do to get other information? All right, so if you haven't done so already, these are the four numbers you need to have for problem number 7. If you haven't done so, write those in already. And then from there, go on. So everybody get those four numbers before I go to the next slide. You haven't, get them now. Okay. Other way. Good job. You got them? You get those numbers? Joshua, did you get that last number? 25? Okay. Is that going to be all right for everybody? And again, I apologize. It's going to be, I know some of these problems are going to require a lot of work. Some of them might not. I think this one might, and a couple of the other ones, they're going to require zeroing in, doing a lot of work. But some of them, not so much. So if we go to the next problem, I'm going to zoom out. This one's not going to be as bad. I'm going to tell you why. All right. T to V. Here is T to V. T to V is 74. We agree? So that entire distance, so if you want to make your life a little easier, and I'm going to put W right in the middle. We said the entire distance from T to V was 74, right? But what do we know about W? W was the midpoint. So if W was the midpoint, each part's going to be 37. So you have 37 from T to W. And from W to V, that's also 37. And that's going to help us because, now they said W to V was 4x plus 1. We agree? So from W to V is 4x plus 1. But we found out W to V has to equal 37. So now, are we at a point where we can solve for the x? All right, really quick, I want you to do that, please, as I update attendance. Okay. All right. Did everybody get a value of x? This one should be pretty easy. Okay, I heard 9 was x. Agree or disagree? Agree? Agree? All right, x is 9. Remember, 37 equals 4x plus 1. And then, again, this is real quick, 2 steps. I should not even have to do this one. Minus 1. And then 36 equals 4x. And then divide both sides by 4. That's how we're going to get 9 to equal x. Again, this one I should not, at this juncture of the school year, need to review. And funny, quite a few of you on the test, or it might have been my other period, thought you had to multiply to get rid of the 4 here. If it's just a plain old 4 times x, just divide both sides by 4 to get the x by itself. Or some of you went from 4x or some similar problem down to x, but you forgot to divide this side by that same number. So some of us made some silly errors on the last test. Gotta be careful. Okay, questions on this problem here? So again, the key is you have to look at what's given, what you need to find. Now, the nice thing was we knew W was a midpoint. So, and that made our lives very easy. I'm just going to write midpoint. All right, questions? Christian, hide that phone. All right. So that's how we knew. Oh, 74. My midpoint says each part is 37. All right, moving on. Okay, a couple things we have going on here. NS, 2x plus 7. S cubed, 5x minus 23. So we have to solve for x. But from N to S, let's say 2x plus 7. And then S cubed, 5x minus 23. Well, what do we know? What do we know about the distance from N to S and S to Q? What do we know? They're equal because they're both part of that. It's just part of that same diagonal. There's our midpoint. So S is your midpoint. I'm just going to write NP for midpoint. That means these two segments are equal to each other. So NS equals SQ. Now, are we at a point where we can solve for the X? Yes. Let's do it. So here's your setup. 2x plus 7. There's your setup. Don't worry about it. I'm so tired. I'm surprised. Don't worry about it. There we go. 2x plus 7 equals 5x minus 23. And then let's solve for x. So I'll give you all a moment real quick to solve out of x. Yeah, some of these problems are going to fool you. They're going to say, they're going to want you to think, oh, teacher just wants us to go this part and then this part. No. NQ, remember, is the entire distance. I'm going to highlight that real quick. NQ is entire distance. And S, I'll underline. I'm going to underline in S. And S is just this part. Yep. And then once these two sides are equal, all you have to do then is just take the first side, multiply it by 2, boom, you get the whole thing. So that might be the quickest way to get that answer. If you want, whatever you get for NS, multiply by 2, there's your NQ.
So let's see.
So in the end, the X is 10 is correct. Then you add 23 to both sides. And again, by now, we should be at a point. I should not have to review solving these types of equations. So again, we're at that point. So X we found out was 10. Did anybody get a value for NS or SQ for that matter?
27.
27. 27. Remember, it's 2 times 10 plus 7. And then to get the overall distance, what's the quickest way? What can we do to the 27?
Times it by 2.
And then what do you get?
54.
54. Yeah, because in this part is 27 from N to S, then S to Q has to be 27 as well. Okay, questions?
Did I ever mention to you anything about kittens yesterday? My friend's cat gave birth to 4 kittens yesterday. The thing is, they have a couple cats. One of them is Hope, this cat. I thought Hope was a female this entire time, but it turns out this sucker was hiding his balls.
Okay, thank you for letting us know about the cat. All right, on we go. Okay, this last one. All right, here's what happened. This diagram, let's see. Okay. I'm going to write, here's how we're going to do this problem. They said K, L, H was 134 degrees, right? Now, if KLH is 134, then we could just say LHJ or JHL must be how many degrees? Well, what must the sum of these two angles add up to be? 180. Grand total has to be 180. So this guy plus this guy has to equal 180. But what do we do with the 134 and the 180 to get that remaining amount? What do we do with these two numbers? Subtract. So what's 180 minus 134?
46.
46. All right, this is key. So 180 minus 134. $46. Now, here is where it's key. Go to the, so that was the diagram on the left. Now the diagram on the right is that same angle, JHL. The entire angle has to be how many total degrees? How many total degrees did we say that entire angle was? 46. So if this part is 25, then this little part has to be, the overall is 46. So from here all the way to here is 46. Say again, it's 21. The little part is 21. This entire part, so they told us KLH, the entire part, was 134. Bingo! That's a winner. You got that right. Very good, Des. Because here's what's going to happen. With your parallelogram, alternate interior angles. So if this guy was 25, this guy has to be 25 as well. But if this guy's 21, then this guy also has to be 21. So 4x plus 9 equals 21. That's how you're going to set up your problem. Very good. That's excellent work there. Couldn't have said it better myself. So well done. So this is your setup. 4x plus 9 equals 21. Again, it goes back to the rules. Now, should only take you a minute to solve for the x. And I'm not even going to go over how to solve for x. You all should know how to do this by now. So, when somebody says the answer, just feel free, let us know. And then we're going to move on. X is going to be 3. Exactly. X is 3. And at this point in the game, I should not have to show you how to do this. You all know how to go down here by now. If not, then that's a major concern. Okay, questions on this problem here. So, yeah, some of these took a little bit of work, but again, it's knowing rules, just general rules. And once we start breaking everything down, it's actually much easier than you think. It's all about looking at every piece, looking at what's given to you. So it looked terrible, but it wasn't. That was actually a real easy problem. But again, it's all about looking at every piece that's given to you and then figuring out what you need to do to solve for the missing values. Okay, does anybody have any questions before we talk about the next type of quadrilateral? But again, piece by piece, you got to look at everything piece by piece. And then again, all the rules are coming back, right? You guys remember, you all remember from alternate interior, supplementary, linear pair, consecutive interior. They're all coming back with a vengeance. All right, here we go. All right, the new stuff. So similar rectangles. We're going to start talking about some rectangles now. Opposite sides are congruent. We agree? Parallel as well. Opposite angles are congruent. And in this case, with a rectangle, all 4 of your angles are what type of angle? Oh, that's not exactly what I wanted to do. So we have a rectangle. Well, what do we know about all 4 corners, all 4 angles of our rectangle? They are
90 degrees.
90 degrees. So you got 4 right angles. Consecutive angles. Well, what's 90 plus 90? 180. So that still works. And then the diagonals. They are congruent. And they're also going to bisect each other. So boom. 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 So it looks like an envelope, like a fancy envelope. Well, once we doctored it up a little. And then again, if they bisect each other, that means these 2 diagonals, boom. And in fact, for the rectangle, they're all going to be the same. All 4 of those parts that are inside, like, well, the 2 diagonals are congruent, and then each side, each part within the diagonal is going to be congruent. And then again, you got 4 right angles. And then really quick, when we talk about if 2 sides of a triangle are congruent, That's an isosceles triangle. What do we know about the angles opposite those congruent sides? They are also, begins with a C,
Congruent.
they're also congruent. So all those little tricks are going to help us. That's how we're going to use these tricks again today. So first problem is going to be, so are we ready for next couple problems? You got one. Let's see, 1, 2, 3, 4, 5, 6 slides for these notes. We should knock them out. And if there's time, we'll talk about the homework, okay? All right, let's have fun. We ready? Set. Here we go. All right, now, couple things. PQ, PS, they gave us those sides. Right away, we can get at least the two outer sides. So QR is also going to be what?
10.
QR is 10. SR is
24.
24. Now, here's what's going to happen. SQ is going to be a little bit of work. But here's how we're going to do it. SQ is this distance from here all the way to here, right? However, if we just ignore all the lines for a quick second. Here's our rectangle. And actually, here's what we're going to do. Boom. There's your line. And, well, what do we notice this diagonal from S to Q? What did it form? So we broke this rectangle up into two what? Broke it up into two triangles. Now, what type of triangle do we have?
A right triangle.
We do have a right triangle. We have a right triangle. So what could this distance from S to Q, if we just look at, all right, I'm going to shade this part in right here. Then it's our right triangle, right? What could that distance from S to Q be? That's our right triangle. We have, then S to Q is our, begins with an H.
Hypotenuse.
That's our hypotenuse. So we're going to use the Pythagorean theorem to get the S to Q bit. So to get SQ, well, actually right now it's going to be SQ squared. Because remember, you have to use the Pythagorean theorem. Here's your hypotenuse. So you got to take the 24 and the 10. But what are we going to do with the 24 and the 10? Are we just going to add them? Or what do we have to do first? Does anybody remember from Pythagorean theorem? Anybody remember what we have to do with the 10 and the 24? Remember, we just did this last unit. Do we just add them up, or what do we have to do first to each of them? We have to,
Square them?
you have to square them first. That's what you need to do first. You got to square them. Okay, we're going to have to zoom out a little. You have to square them. So you have to take 24 squared and then 10 squared. So what's 24 squared? What's 24 times 24? And then what about 10 squared? How much?
100.
All right. So then what do we have to do with the 576 and the 7 and the 100? Add them up. So it's 676. So let me put this. So it's 676 equals this S cubed, but that's squared. But what do we have to do now? Can we just say 676 and have a good day?
No.
No. What do we have to do with that 676?
Are you doing a divider?
Not divide. How'd you get 26? Bullseye. That's it. You got to square root that. 676, you got to square root it. So then, in the end, SQ is going to be 26. So that entire distance from S to Q is going to be 26. Now, that entire distance from S to Q is 26. Well, what about from P to R?
The same, 26.
It's also going to be 26. Same thing, because SQ and PR are the exact same. So they said that entire distance. Now, what about the distance from Q to T?
13.
How did you get 13?
You just divided in half.
That's right. That's all you do. It's going to be 13. 13. That's all you do. It's Q2, you take it's SQ divided by 2. I'll write that on the side, but yeah, that's how you get that one done. That's how you get Q2. And then, of course, SQ and PR are equal. They're both they're both diagonals. Okay, does anybody have any questions on how we got this? Anybody have any questions on that problem? So again, it's all about pieces. So again, we learned a couple things. Midpoint. Bisect. And then your diagonals, if you want to find that diagonal, is basically Pythagorean theorem to get the diagonal. So I'm going to write Pythagorean theorem to find diagonal. And then sometimes you might get the diagonal in one of the legs. On the other leg by Pythagorean theorem as well. So all these rules from unit 1, 2, maybe 3, and 6 are coming back with a vengeance. All right, any questions up to this point? All right, go to the next one. Yes, I think the next one might be the hardest one, but once we get through it, I think everything else gets easy. It may not be as bad as you think. All right, let's talk about this. All right. I'll be honest, they only gave us one angle. Yet, what's up? Go ahead. Fire away. Let's see. Tell us. Why? Yeah, she's right. MJK, boom. Yup. Very good. Yeah, because M to J and the L, that's 63. JLK, yeah. I'll give you that one. That one's also going to be because you know what that's called, alternate interior angles. Hold on. We're trying to catch up to you, Des. Hold on. I'm going to rewrite this one in blue. I want to try to color coordinate everything. And then you said KML was what? What again? Okay. Yup, KML has to be 27 because if this one's 63, and since these diagonals are congruent, this one's going to be 63 as well, which means this one right here, KML. Oops, sorry, my writing has been off. Has to be 27. Very good. She hit it. Because remember, these two angles, the 27 and 27, they have to match. And then this one right here, I know how you got the 126. That's perfect. Your answers were perfect. And the reason Des got 126, oops. Because what happened was MNL, she knew, here's what we're gonna do, everybody. Make this a little bigger. That might have been too big. Zoom out a little. All right. What happened, how Des got the 126 was the following. She took this small triangle right here. I'm going to highlight it. M and L. Here's what Des did. M and L. These diagonals were congruent because that's with rectangles. Diagonals and their little subsegments are going to be congruent. We found out this angle was 27. That means this angle also has to be 27. And then the last part right here, it's going to be, she had to find the difference. So it was 180 minus 27 minus another 27. So that's how we got that 126 up here. So excellent job. Okay, anybody have questions on any of these four angle measures? Because that was great work. And again, it's all about a combination of labeling, knowing what's given to you, and then basically working backwards as well. And then also the rules about isosceles triangles, midpoints. Because in the end, all four of these diagonals were the same in the end. Boom, 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 boom. So that means their opposite angles are going to be congruent. And then you get this angle and that, or this angle right here, because the sum of the three angles is 180. If you already have two of them, just subtract 180 minus the 63, subtract 63, or 180 minus 27, minus another 27. Bang, done. So that problem took, what, maybe 2 minutes, 3 minutes? It's all about knowing them rules, understanding them rules. So that's great work there. Because we're going to be using these rules again for a couple more of these problems. Does anybody have any questions? The key is understanding how we're getting these numbers. All right. Okay, we're almost done. I think there's only, what, one more page, front and back? All right. So we got two-part problem. So for problem 3, well, what do we know about the rectangle? What do we know about their opposite sides? They are, well, the angles are 90. So I agree, we got 90-degree angles. But what do we also know about their sides? Similar to the parallelogram. Opposite sides are congruent, so that means their measures are equal. That's right. So, yeah, EF and DE are gonna, or DC rather, are gonna be the same. So step 1, what do we know about these two sides? They are, somebody said it, they're congruent. So that means we said 7x minus 39 to equal what number? Or to equal what expression? 3x plus 5, because they're equal to each other. Yeah, boom. Set them equal. Now, are we at a point where we can solve for the x? I want y'all to hit that real quick. Solve for x. So I want y'all to solve for x and then find the value of EF. So once you get your value of x, plug it in. So get your x, boom, plug it in right there. Meantime, we're gonna from a neighbor. All right, what did we get for x?
11.
All right, 11. And then what do we get for the distance from E to F?
38.
Exactly, well done. E to F is going to equal 38. Good job. Okay, who has questions? Who's not sure how we got the x equals 11? You better be honest. I mean, then subtract 3x. Minus 4x minus 39 equals 5. And you add 39. So you get 4x is 44. And then, of course, multiplied by 4. And that's how we get the x equals 11. And then plug the 11 in. It's up there. 7 times 11, 77 minus 39. That's how we get 38. Okay, questions? Not too bad, right? Okay, here we go. Okay, this is going to be a little bit of work. Well, here's what we do. This should have been find x, rt, then vt. They said vt is the ultimate goal. So the ultimate goal, we have to find vt, which is here. But before you get vt, you really need the entire distance, r to t. We also need, but they also gave us RT and US. US is here. But what do we know about the relationship between RT and US? They're the same. So yeah, RT equals US. So that means we can say 5x minus 14 equals 2x plus 10. And now are we at a point where we can solve for the x? Do it. So get your x, and then you're going to plug it in. You first need RT. It's going to be 5 times whatever you get for the x, minus 14. And then what do we know about the relationship between RT and VT? Well, what do we know about VT? VT is exactly what of our RT? Because remember, VT is at that midpoint. What do we know about the midpoint? Midpoint divides the entire segment into two equal parts. So VT is basically RT divided by 2. And then you get your value. So I want you all to try that one. It should only take like 2-3 minutes to knock them out. Because we know how to solve for these types of problems by now. I'll come around to check. Oh, I see where you're going. Okay, that's fine.
That's right.
Let me see. Okay, you set them equal. Good. Yeah, what you did was perfect. Well done. Did you get that other one real quick? No, the one before. Yeah, you got it too. Great job. Good work there. Yep, you got the X. Good work. And then plug them in. Yeah, that's perfect. Good job. Perfect. That's great work. Use the X. All right, this is how we're doing here. Okay, you got the value of X. Good. You got an RT. So then what do you do to the RT value to get VT? Yep, you're just about there. Good. Okay, I know you got it. Barry, how do we do here? That's perfect. All right, great work. Yep. So then what do you have to do with the 2 and 6 to get that last value? Divide by 2. Just divide the two numbers. You got it. You're there. Mm-hmm. Good. And then divide that 26 by 2. There you go. You got it, Edwin. Good work. All right, here we go. Real quick. What did we get for X?
8.
All right. And at this juncture, I'm not going to go over it. X is 8. And then, what about RT? So take your 8. What does RT turn out to be? RT is? Yep. And then what about VT? 13, good. Good work. Yeah.
Would it be like these two equals 90? Would it be like that?
You could do that. Very good.
Okay.
Yeah, that's really good work. All right, yeah. All right, we're gonna get there in about a minute or two. All right, questions about these? X was 8, RT was 26, and then VT is 13. All right, y'all did good work on that one. All right, this next one. All right, here's what we have going on here. What do we know about the relationship of these two angles? Say again? Yeah, they're the same. So there you go, right away. Boom. Set it up. 7x plus 5 equals 11x minus 3. There you go. There's your setup. And then what you do, get your x, and then for DCE, it's just a plug-in. 11 times blank minus 3. Now, for BCE, what could we do? Well, what do we know about that overall angle from here all the way over here? It's how many degrees? How many degrees is it, the corner? How many total degrees is our corner?
90.
90. So what we could say is BCE is just 90 minus a measure of DCE. Do we agree to that? Because DCE is right here, right? That means BCE is just 90 minus DCE. Do we see where we're going with that? So there you go. There's your two clues. Have at it. So once you get your X, boom, plug it in. Get DCE. And then once you get DCE, boom, you're going to get, you get BCE. Just take 90 away from that, whatever number you get. So we're going to check. get that x. Okay. So you got, all right, so you got 2 out of the 3. Then once you get that number, subtract those 90 minus that number to get that other angle. Yep, you got it. You got it. Perfect. Okay, so you got your x. All right, you're on your way. You're getting there. You got the x. Mm-hmm. Good, you're on the way.
So,
What's well, no, no. What are you dividing both sides by? Where's your x? Well, what are you supposed to divide both sides by? 4, maybe? Good. You got it? Yep. Okay, so subtract what you got for DCE, 90 minus, and then you got that last one. Yep, you got it. Mm-hmm. Good work. All right. So what did we get for x? X was 2. X is 2. Then DCE was how many degrees?
DC
19. That was 19. And then the last one? What was the last one? 1971. All right, good. Okay, now the last one really quick. All right, so good on that one. All right, last one. And then I'm gonna come around and check what we've done. All right, somebody said something that was very important. This triangle. Well, what do we know about this angle right here? This angle is how many degrees? 90. So what must the other 2 angles add up to be? Because if we already have 90 degrees, and this is part of a triangle, what must these other 2 angles, what must the sum of the other 2 angles add up to be? Somebody said it. Catherine, I think you said it. Or maybe it was Des, one of you two.
So it's, yeah, it's both of those things equals 90. That's like the 180 thing that just switch 180 for 90.
Right. All right, perfect. Because in the end, you already have 90 degrees, right?
Yeah.
Therefore, the other 2 angles has to add up to 90. So your setup is going to be x plus 20 plus 5x minus 8 equals 90. That's where we get that. Good. You have a right angle here. Then these 2 other angles have to add up to 90. So this is going to be your setup. Did anybody try this? What did you get? X is 7. Yep. Yeah, you get 6. Wait, X was what again? Okay, 20 minus 8. Okay, 20 minus 8 is 12. So 90 minus 12 is 78. Okay. Check. I mean, I'm getting x equals 13. Anybody else?
Yeah.
You sure?
Yeah, I got x equals 13. Yeah, it is.
Yeah, so x is going to be 13 in the end. Because remember, this is going to be 6x plus 12. All right, so really quick, I'll give you the last two. X is going to be 13. And then xz or xew. Okay, because this is 33, 57. The other guy has to be 57. So so just type them in. And then I'm going to come around real quick. Okay, good, good, good. You write those last two in. Good, good, good. I'll give it to you. Good. Barry, can I see you? Alex, that's good. Barry, that's good. Catherine, that's good. Okay, I'll take it if it's ready. I apologize, I didn't get the last one. Okay, show me them, you'll get my credit.
I will add
Okay, finish it, shows me you'll get full credit.
those.
Alright? Alright, I apologize, we didn't have too much time to go over homework. If you've completed it, I'll take it. If you have it, that's okay. I'll give it back. You'll have, yeah, I got you. You're gonna get full credit.